Okay, so the final example we're going to look at is we're going to look at again our set C, where C is the set including A, 3, 90, Y, and 7. We're going to ask ourselves, how many subsets does C have that have size 3? Or how many subsets of C, if you look at the total number, if you look at all of the subsets, have 3 elements? How many of them have that? So if you were to draw C as this big circle and you were to draw all of its subsets, C has 32 subsets. If we remember from our formula, 2 to the power of n, where n is going to equal to the number of elements in C, which is going to be 5, because there's 5 things here. So it's going to be 2 to the power of 5, and that's equal to 32. So there should be 32 dots here, right? And we're going to be approximate. I'm not going to write down all 32 of them. And we're going to ask ourselves, how many of these dots that represent a subset have 3 elements in them, right? And it could be the number of dots in this area here. That's what we're basically asking. So how are we going to compute this? Well, we already know that we can use a nifty little trick called the choose notation. So the choose notation works like this. When you say n choose k, what you're saying is the top number is going to be the total number of elements in the set you're asking about. So in this case, it's going to be the number of elements in C, and then k is simply going to be the number of elements in subset we want, right? So in this question, it's going to be n. As you remember, we did 2 to the n. These n's are the same number, so we know n here is going to be 5 because C has 5 elements, so it's going to be 5. Choose k. What is our k? The number of elements in the subset we want. Well, we want size 3, which means we want subsets that have 3 elements. So it's going to be 5, choose 3. Now, how are we going to compute this? Well, we know that this notation is simply the same as saying 5 factorial over 3 factorial multiplied by 5 minus 3 factorial. So how do we compute that? Let's quickly write out what 5 factorial is, which is going to be 5 times 4 times 3 times 2 times 1 over 3 factorial, which is 3 times 2 times 1, multiplied by 5 minus 3 is 2, all factorial, so 2 factorial, which is 2 times 1. Fantastic. What do we notice here? Well, the 1's here cancel, the 2's cancel, and the 3 here cancel. So what we're asking is 5 times 4 over 2 times 1. That is really what we're computing here. And what if we final is the same as saying 20 over 2, which is going to be 10. Fantastic. So we know the number of subsets of size 3 that C has is going to be 10. Something interesting to note here is that when we did the previous example with the set B, B had the same number of elements. Doesn't matter what the elements are. Remember, we don't care what the elements are. The only thing we care about is how many elements there are. And what you notice is it appears to be that a set that has 5 elements has the same number of size 2, and in this case, size 3. We got 10 for B, and we got 10 for C. If you wanted to compute size 4, simply go ahead and replace this 3 with a 4, the 3 here with a 4, and the 3 here with a 4. You would get that this is 2 times 1, because 5 minus 4 is 1, so 1. So multiply by 1 here. 4 factorial is simply going to be 4 times 3 times 2 times 1. And you'll notice that the 1 cancels, the 2 cancels, the 3 cancels, and this time the 4 cancels. And what you find is the same set C, in fact, has 5 subsets of size 4. Fantastic. So I think now we've gotten used to using this type of notation. Something I really want to note at the end of this miniature chapter here is that this notation does not care about order. We don't care about the order of the sets or the subsets we're counting. We're just counting them, right? The same way when you're counting the number of elements, you don't have to count them from left to right. You can count them in any order you want. We could say 1, 2, 3, 4, 5, or we can count 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, right? The order with this notation when we're counting with these problems so far does not matter.